Yeah, hello, welcome to another tutorial for our project, and this is project 2 for module 3. Um, it is a continuation of the one that we did last week. So I will urge you to follow suit and then try to also do the same. This is our question, or this is our, let me show you. So this the project instructions, I should say, although it is like a chart, but that is the instruction. So um, that is a continuation of last week's one. So you see that Aziz Naledi says something here. Our mission, as arduous as it is essential, requires us to delve deeper into our reservoir of data. To truly illuminate the road ahead, we must magnify our analysis, moving beyond isolated data points to discern larger patterns and trends. So basically, she's trying to say that we will move deeper into our data sets and analyze them. Okay. And then Chidi came to talk about what there's, I think, the inconsistencies in the data we found last week. Last week there were some inconsistencies. I think one of the uh, tables we found it. I have forgotten, but that is what happened. So Chidi was drawing Naledi's attention to that, and then Naledi appreciated that, and then the next one is we doing the work. So before we start, scan through the data dictionary and perhaps query a couple of tables to get a feel for the database again. So please, as at now, if you don't know what the database is all about or the meaning of the database that we have, you should uh, have a real look at it, because if you don't understand what is happening in the database, whatever we are doing here, you will just watch the video and it will not make sense to you. Yes, it will not make sense to you, because look at this table. We have employee table. So when you open the employee table, you should know what is happening there. When you open the employee table, for instance, the employee table, you should know that this is employee ID, employee name. You should know the meaning of the columns, what they mean, and what their data types are. So you should know all of them. If you don't, some of the column you don't know the data type, you can go to the dictionary, or you just click on the table like this and come down here. You see the column data type here. So you see name and then the data type, region and its data type, year and its data. That is under global water access. It is not for this one. It is for global water access. Okay. So let's continue cleaning our data. So, okay, bring up the employee table. It has info on all of our workers. But note that the email addresses have not been added. We will have to send them reports and figures. So let's update it. Luckily, the emails for our department are easy. First name dot last name at indogowater.gov. So we will take the first name and concat it with last name. You remember that we've learned concat. So if you have read through the models, you will know that there's a function called concat. And concatenation simply means that you are adding two or more strings together. So we can determine the email address for each employee by selecting the employee name column, replacing the space with a full stop, make it lowercase, and stitch it together. So we will take the first name of the employee and the last name and put a full stop in between them. And then we do what? we add the at and then ndogowater.gov. So we will add this at ndogowater.gov to the first and last name, the space in between we put a full stop. Then we form their email address. Now it looks like I have done it already. So this data has been tampered with, but I will still show you how I did it. I don't want to go and download the whole data again. It will take a lot of time. So here is it. So I have this one. Let me remove the comments. So we have select, and then we want to display employee name. So in this case, it will display the employee name, then it will display something else, and that then is the email addresses. Okay, so this is what we are doing. We say concat. Let me remove this. So we concat, and we want to concat first name like this, our first name, and then we put a dot in between, and then the last name, and then we add at ndogowater.gov. So this is what we are going to do. Since we know the first name as we know the first and last name to be in the same column. Let me check. It's here. Employee table. Good. So this is the first and last name under what? Employee name. So under employee name, we have the first and then the last name. Now, how do we identify the space in between them? Okay. So let me show you that. Hold on. Let me put the employee here so that I can reference it easily. So let me paste this. So this is what I did. Employee name. So concat employee name. This is what I did. So employee name. Okay. Then we go to the employee name table. Sorry, let me try and then let me comment this out and then do it one by one with this. Let me put it down so that so this is what we are doing. We are saying that concat, and this is what we are supposed to do. Employee name. Okay, so employee name, but in our case, employee name contains both the first and the last name. So if I do employee name, then I concat it with logo what let's say at ndogo water.gov. If I do this, the outcome, so let me close this and show you something. So if I do this, this will be the outcome. I have some things here, I haven't commented them out. I don't want them to run. Let me comment them out. Good. So I have this. I have select employee name is here, and I have concat to be here. So I'm saying that combine employee name with at. So that is what I'm telling there from this table, employee name, employee. So look at this. Hold on. Maybe I've typed something wrongly. Select employee name, concat employee name as Let me do this as email. Let me see if that one works. Yeah. So this is what is happening. I have the employee name. So you see, it takes the employee name and then add at dogowater.gov. But that is not what they are saying. They said there should be a dot in between this Amara and Django, Bello and Azebo. And they should all be small letters. Okay. They should all be small letters. And so we use replace. So replace is what is going to look for. Replace is going to look for replace is going to look for the empty space and then replace it with. So inside the concat, we are going to write replace and replace something in the employee name where the employee has a space. So this is how it's going to be like. So we'll have replace, then we put a comma at the end. Please forget about these ones. So this is the replace. Let me close it so that you see it. But replace takes what text you are talking about. Then you bring your comma. And then the next one is what particular text are we talking about within this text? So what particular text are we looking for? Is it a space? So we want to look for a space, not any other letter. So we are looking for a space in the text, then comma, then we replace the space with what? A dot. So I'll put it in quotes. So anything text, you put it in quotes. So look at this. You see that this is in quotes, the dot is in quotes, the space is in quotes. So I am saying that look inside the employee column, any row that has a space, that has a text with a space, this space, replace that space with a dot. And then, so when you replace that space with a dot, it means it will return the text together with the dots. Okay, so this time around it will replace Amara dot Django at. So this is what will happen. So this replace is complete. If I run it, this is what is happening. You see that there's a dot. Now we have completed this phase. Now we are supposed to make everything small it is. So the concat is putting everything together like this. Okay, the concat has put everything together. So this whole thing, this whole concat with replace and all that is returning these texts. So if we have these texts, so this first one will go through this and return this Amara.Django with caps. Now I want to change everything to small letters, and when you want to change everything to text to small letters, you do what? Lower. So I place all this inside lower formula. It is like I'm placing Amara.Django at whatever inside lower, so that it will change the whole thing to what? Lower. So I'll type lower and bring a bracket around this. Okay, so you see that this bracket is closing this lower. Wait, this bracket is closing the replace, and then the concat has this bracket, and then lower is also closing the whole thing. Okay, so lower is closing from here up to here. So that is it. Then we say as maybe email or whatever. So now we can run it again, and you see that what we wanted to achieve has been achieved. So when you come here, it says that we have to what? Do select, so everything is here, replace, lower, everything. So we have done it, and then they said we should go and update the employee table. So this is what I did, and it affected my table. So when you come here, you are supposed to what? Update. So with the formula, we go ahead and then update. But first, you write set SQL save update 0. It was said in the one of the videos. Then we do updates. So update the employee table, then set the email column. In our table, we have an email column, but this email column didn't have, in your case, your email column doesn't have anything. It is now. So this is what is happening. We are saying that we should set email to whatever we did, the one we did up here. We are changing, we are combining the names of those people with a dot inside and then at logo water. So this whole thing will now be equal to the email. Okay, so the whole thing will be now be equal to the email. So if it is equal to the email, then we are going to replace, or we are going to set the email to that what we created, where it is now, where the email is what? Now. So we have the where keyword, then it's now the email. So anywhere in the email where we have now, it will forge this our email that we have created and then put it there. So the emails that you see here, it will replace the email with it. So this column, for instance, it is a column that we created. It is not part of the table. This one is our own column that we created. Okay, so it means that at the end of the day, this is what you are going to run. You are going to run from here to here. So set SQL save update is equal to 0. Then update, then we have this update from the employee table. Then you set the email to the email you've created. Okay, so the email you've created, then you give it a condition where the email that you the email column is what? Now. So when it is not now, it will not replace it with that. So at the end of the day, your table will be altered. If you don't want to change it to, you just ignore this particular one, so that you only use the first one that we did. So this first one, it's not going to affect the table itself. It is just going to show the results. Okay, so it will not affect the main table. So let me also comment that one out and move to the next one. Okay, so the next one is I picked up another bit we have to clean up. Often when databases are created and updated, or information is collected from different sources, errors creep in. For example, if you look at the phone numbers in the phone number column, the values are stored as strings. The phone number should be 12 characters long, consisting of the plus sign, area code 99, and the phone number digits. However, when we use the length function, it returns 13 characters, indicating there's an extra character. So you see, they know that the phone numbers has to be uh, 12 characters long. So look at this. Hold on. So let me type that. So select or let's say select length of phone number or phone, is it phone number? has stand to be corrected. So select from employee. Let me see if that one works. Okay, so we have the phone number being 12. In my case, I've corrected it already. In your case, when you type this formula, it will give you 13, meaning that our phone number. So let me show you the phone number column. So phone number. So I'm showing you the phone number column as well. So you see the phone number is here. When you count it, it should be 12. But in your case, because you haven't changed it, you will see that it will be 13. Meaning the text here, you see that when you count them, it is 12. But then the length is giving you 13. It means that there's a white space after the numbers. There's a space which you can't see, but it sees the space as a text. So it is counting it as part of the length. And so we have to remove the space. And removing the space, we use what? Trim. So trim is going to remove the space. So in our phone number column, if you don't want to change it permanently, you can use trim on the phone number and then display them. Okay, so but when you trim and you display, you can't see the you will not be able to see the effect unless maybe you write length trim phone number. So when you do length trim phone number, you see that at the end of the day the length will be what? 12. And if you change it in the table itself, that one too is there. So when you change it, it is update the employee table. So this is the employee table. Set phone number equals what? Trim. So we are going to set the phone number column and then we trim it. Then we assign it to phone number. So it will take each number and then trim the white space, remove it. It's like you cut it off and then you place it here. Then you come to the next one, you cut the white space, you place it here. You place the number here. This one, you take the whole number, cut the white space off, then you place the number back. So that is what it's doing. So it will trim the phone number and then put it back into the column phone number. So, and then it will also check when I check the length of the phone number when it is 13, because some of them it may be that they are not 13, they are less than 13, maybe they are 12. So if they are 12, then there's no need to what? Trim it. So the ones that are 13, it will trim all of them and then give you the result. So that is the update for that one. So I realize that one, it won't really affect me when I move on with my work. So we move to the next one. Okay, so here I've already gone through the whole thing with you. So it came here and said honoring the workers. Before we dive into the analysis, let's get you warmed up a bit. Let's have a look at where our employees live. Use the employee table to count how many of our employees live in each town. Think carefully about what function we should use and how we should aggregate the data. So we want to know how many employees live in each town. So when you take a town, how many employees live there? Okay, so when we go to the employees table and we select, so if I do select, let me leave enough space so that these things will not make us so now if I write select all columns from the employee table. Now we have some towns. So when you come here, you see that we have a town here. We have some towns that Dahabu, we have Hare, Kintampo, we have Lusaka, we have Zanzibar and all that. So we want to know how many of their employees live in a particular town. You see that we have this town, each employee has the same town. So in this case, even in this case, we have this town again here, 3, 4, 5, 5. I think there are 6 also in this particular town. So how do we write something that will show us that this number of people are staying in this town or in this town? Okay, so let's try and write something. So I'll try and write town. So we start with town name so that it will show us a town name. And then since we want to look at the number of employees living in a particular town, it means that if they wrote a town name here and they wrote it again, it means that these are 2 different employees but the same town. So when you check it here, this is assigned employee ID 36, and then the name is this, and 46 is a different name. So these 2 employees are coming from the same town. Okay, so it means that when I count the number of towns, the particular towns there, it is equivalent to the number of employees in that particular town. I hope you understand. So we write town name, and then I can now say count. So I will count the town name. Okay, town name. Now when I count the town name, this town will give me, so it will give me the town name and then the number of towns. So I think that is what it should give me. But when I run it, it doesn't, because the town name here is returning something that is more than the count, because the town name Dahabu can return, it can return more than 3 or 4 Dahabu. But then in the count, it is counting all Dahabu and is supposed to place it in Dahabu, in front of Dahabu. But it is not likely it will write Dahabu 36 or 4 people, Dahabu again 34 people. So we try to also group them. So in this case, you can say group by, so we group them by what? Our town name, so that the town name will appear once. When we group it by town name, so if you have the Dahabu, it will write the Dahabu once. If you have Hare, it will write Hare once. Okay, so that is what will happen. So this is, when I run it, this is what happens. So you see that we have Ilanga, then it has 3, Rural 29, Lusaka 4, Zanzibar. So you see the Dahabu that we counted, we got 6. So that is it. And then this thing, the count name, we didn't give it a name header for the column. So we can say as, let's say, number of people, something like this, or number of employees. Okay. So this is what it is returning. But then I want to also order it. They are not, I don't know whether they said we should do that, but I want to also order it so that I'll see the highest, the town with the highest number of employees. So I can say order by, but order by, because the number of employees in our case, this number of employees, we created it. It was not part of the table. So I cannot write order by, then I write number of employees. You see that I just created it as, okay? So I cannot write this here. When I do that, it will throw an error. But what am I saying that it should be named like this? It is this thing that I'm saying. So it means that I can copy this formula and place it here, so that it will order by the number. the number of employees here. So when I run it, this is it. Now it is ordering by in ascending order, okay, by default. So I want descending, like from the highest to the lowest. So the highest is rural, and then the Habu is the second, then Hare, like that. So I think yes, that is what he's here. So he says, I got this, or I get this answer. And that is exactly what we got. So note how many of our workers are living in smaller communities in the rural parts of Majindogo. President Naledi congratulated the team for completing the survey, but we would not have this data were it not for our field workers. So let's gather some data on their performance in this process so we can thank those who really put all their effort in. President Naledi has asked we send out an email or message congratulating the top three field surveyors. Top three field surveyors. So this one is a key. So let's use the database to get the employee IDs and use those to get the names, email, and phone numbers of the three field surveyors with the most location visits. So this is what we are going to do. We are going to visit, or we are going to look at the visit table and then look at the employees with the most visits, okay, who had the most visits to towns or the whatever, and then get the top three who are also field surveyors. And when we get that in the visit table, we don't have any employee name there. And so when we get the top three, we will get only the employee IDs. And when we get the employee IDs, we come to the employee table and then point those IDs there or search for those IDs, which will return the names of the employees. Okay, so we get those IDs to get the names of the employees, their email, and then their phone numbers. So let's get to that. So here it says, let's first look at the number of records each employee collected. So find the correct table, figure out what function to use and how to group, order, and limit the result to only see the top three employee IDs with the highest number of locations visited. So let's see. I think this one is okay. So I had this. That is what I have here. And then this one is what we are talking about. So we have this formula. We are saying select assigned. Let me bring it down. So we are selecting assigned employee ID. Maybe you want to see the employee table again. Let me show you so that you will not get confused about this one. So let's do select all employees or all records from the visits. So we are pulling all records from visits table and see this. So we have assigned employee ID. You see that this employee ID will tell you the name of the employee in the employee table, because the employee table, it has assigned employee ID together with their name. But here we don't have their names. So when you see 12, you don't know who it is. But then they are saying that we should look for the employee who had the most visits. Now, this is what happened. We said we want to select the ID first, and then we count the assigned IDs. Now here, in this case, these IDs appear, some of them appear as many as they can. Because look at this. This is a location, and this person can visit this location, and the same person can visit another location somewhere. Okay, so in this case, the ID will appear more than once. So here you see 40 here. Let me go down. You see another 40. So in this case, this employee visited this particular location at a source at a particular source, and then visited this location too at a particular time or from or another source. So we are counting the number of times the employee ID appeared, which is also equivalent to the number of visits, because when you visit, we record, and then we write your ID, then we record the location, the source, the time, and then the visit. Okay, so we are going to count the IDs. Then we say number of locations visited, then from the visit table. And then we group by what? Assigned employee. Because if you don't group it, it won't work. You have to group it so that, because please, what you should put in mind is that whenever we group it, we want to get unique numbers. So this 40 will appear once when we group it, because when we group it, it will take all the 40s and put them together as one entity and tell us that the number of 40s are what, 15 or 20. So when you take 12, it will write 12 only and then tell you the number of 12s are this. So that is the grouping we are talking about. So after grouping them, we try to order them by the number of locations visited. And the number of locations visited is what? Count assigned. And that is what we brought here. We brought that thing here. I've told you that you cannot write this here because that is what we are now creating. So if we are creating, we will have to bring the count assigned employee ID. And then after that, so let me remove this. After that, we bring in descending order. So that is the highest to the lowest. But then we limit it to what? The first three. Because they want us to get what? The top three employees. So let's run this and see. Good. So after running this, you see that we have the assigned employee ID as we have here, this first one. And then we counted the employee IDs as number of locations. So we have number of locations visited. So you see that the first person with the ID 1 had 3,708 visits. And then the one with the ID 30 has 3676. And then the third one has 3539. All right, so we have finished that phase. So now we have the IDs. We have these IDs 1, 30, and 40. But you don't know the names. You don't know. So we have to go to the employee table and look for them. So when you look at this table, you will not really see that it matches with ours. But then when you look at this one, the one, assigned employee ID 1, you see that it is still 3708. So it should tell you that you are right. Just that in this case, they have mixed it up. I think they rather started from 0, 1, 2, 3, so that it will just arrange this one in ascending order, descending order, or ascending order. I think ascending order. Then they will just do this one. So if I come here and I do ascending order, sorry, for if I don't do it for this count ID, but wait, is it the ID? Yeah, it's still the ID, not the on the visit. So if I do it ascending, uh, order by, okay. So if I do, that means I want to do, order the employee ID. So it means I have to do order by this and the other one. Okay. So let me try it. It's a try. I want to see if I'll get whatever is there. So I'll add this one. Okay. Um, Okay, so let me run this and see. Okay, so when I do it this way, you see that it shows what he got here. All right, that is not what we are. We want to arrange ours in such a way that we will see the you will see it in we will rather um, um, arrange it in descending order using this criterion and not with the IDs. When you use the IDs, you will not be able to know the highest to the lowest or the first highest or the top three. Because in this case, you see that we have 1099 and that is not the third person. The third person had 3539. All right, so I think that is that with this particular one. Okay, so let me comment this out. All right, so from there you know that you are right. You have your 1, I think 30 and 34. So make a note of the top 3 assigned employee IDs and use them to create a query that looks up the employees info. Since you are a pro at finding stuff in database now, you can figure this one out. You should have a column of names, email addresses, and phone numbers for our top docs. So please send that off to Presidentality, but this survey is not primarily about our employees. So let's get working on the main task. We'll start looking at some of the tables in the data set at a larger scale, identify some trends and summarize important data and draw insight. So we are going to look for those employees, display their names, email addresses, and phone numbers. So when we come here, this is it. So we selected the employee name, address, and phone number. Okay, so this alone will display all the employee names, address, and phone number, but we want some specific employees. So you add the where condition. Okay, where condition. Imagine if I take this off and I run this. This is what will happen. So this one, it doesn't make any sense. We won't know what is happening. So I'll place the where condition after that okay, display employee name, address, phone number where the employee ID is 130 or 34. So it will display only these 3 people, their name, address, and phone number. So when I run this is what is happening. Okay, so these 3 IDs are what is here. If you doubt, you can even add employee ID here so that we'll see their IDs. So you can say assigned employee ID. If I do assigned employee ID and I run, you see that it is here 130, 34. Cool. So you see where assigned employee ID in, it means that all these things, it will consider all these IDs in that column. Okay. It is when you can go and write it as where assigned employee ID is equal to 1 or assigned employee ID is equal to 30 or assigned employee ID. No, that one will make a lot of it will give you a lot of work. So when you write assigned employee ID in 1 30 34, it is the same as writing assigned employee ID is equal to 1, assigned employee ID is equal to 30, or assigned employee. So this one is shorter and simple. Okay, so this is exactly what they wanted. So when I run it again, I'll have Bello Azibo. This is the address and whatever is here. So we know our top 3 employees. We know our top 3 employees. I think one or two of the questions in the quiz was, some of them were asked based on what you did in the project. I think this time around you try to add one or two of them. So please, you have to be vigilant about what you are doing. All right. Now let's move to the next one. It says analyzing locations. Looking at the location table, let's focus on the province name, town name, and location type to understand where the water sources are in Majundogo. So we look at location, the province, town name, and location type, and we run. Okay. And they said we should create a query that counts the number of records per town. So a query that counts the number of records per town. So we take the town name, we count the number of towns. So number of records per town. That is what I did here. Let me bring this one down. Okay. So it will display the town name and then the number of towns for that particular town. Then we group them so that the town name will not appear double or more than one. And then we order by the town counts. So we order by the number of town in descending order. So this is what is happening. So you see in descending order, rural has the highest number of records per town. Then Hare is the second, and Amina and Lusaka are like that. So that one is done. So you see it here. Now count the records per province. So we went to province and counted the numbers per province. So it's the same formula, but this time around, instead of count town, we'll have what? Count province. So that is what is below it. So instead of count town, we'll have count province. So this is it. So when you run it, you get per province. Okay. So let me comment it out. Then move to the next one. So if you don't understand anything, you can go back on the video, or you can private chat me if you still don't understand. Then I'll take you through. But please, nobody should contact me concerning the quiz. The quiz is for you to do it on your own. I am not supposed to give you the answers to the quiz. I'm also a student like you, and we are all doing it for our understanding. We are not giving, we are not giving answers to people to get 100% and then just move ahead. So those who have been contacting me about answers, some of them can testify that I don't give them answers. I give you explanation as to what to do so that when you look at the quizzes, you cannot go through it. Because some of you have realized that you don't go through the models, you just watch the video and then you want to go and do the quiz through friends. Please, if you don't understand the models, whatever I see in the video becomes meaningless. You watch the video all right, but you will not understand. Because I presume that you have gone through the models and you have understood the commands and all that. But then some people, they won't go through that. They will come and watch the video and then the video will not be very effective for them because you don't know anything about select statement, you don't know anything about where statement, you don't know anything about max, min, and all that. But then you still want to do the project. It becomes difficult for you. So please go through the models first before you watch this video. And when I assure you, when you go through the videos thoroughly, or you go through the models thoroughly, and you understand everything that has been put there, and then you also go through this video, or this project, I bet you can do the quiz easily. Okay, you can do the quiz easily. And please, whatever we do, you practice it. Whatever we do, you practice. Whatever I'm doing with the project, you practice it. Even if you not practice anything in the model, just practice the project. For me, for instance, I don't do anything in the model. I don't practice it. It is only one or two of them which I want to test it and see if I can also do it. But when it comes to the project, that one, you have to practice everything because the project is likely to test you on everything that has been spelled out in the model. So please, let's do justice to that so that everything will run smoothly for us. Me not giving you the quiz questions doesn't mean that I am difficult person or something. I just don't feel it is not even a belief. It is not my belief or it is not, it's just my nature. I don't like giving out answers just like that. When I give answers like that, I feel like I'm being wicked rather by giving you answers to get something 100% which you don't have any idea about. You have to understand it. This is not a WASI or BEC for you to pass and then you move to the next level. No, this one we are going to use it in our field of work or we are going to use it in the real world. So we have to really understand it. You are a data analyst and you don't know how to analyze data, how to use data to do things. It becomes a little bit difficult. Yeah, because someone was telling me that if I should give it out or I should do that. Whatever the person uses it for, it shouldn't be a problem to me. But me, it is a problem to me because I am doing the harm. So if anything happens, I did it. So I don't want to involve myself in such acts. So if you tell me that I should give you answers, I won't. So don't even DM me about it or tell me that, oh, you are opening your quiz, you want me to help you to answer them. No, yeah, I have a group, and that group we don't do that. They even know that we don't give answers out. We just discuss and then we understand the whole concept before we engage in the quiz. So that is that. Let's move on. So from this table, it's pretty clear that most of the water sources in the survey are situated in small rural communities scattered across Majindobo. If we count the records for each province, most of them have similar number of sources. So every province is well represented in the survey. Can you find a way to do the following? So the following here, they are asking you how you can do it. So they say create a result set showing province name, town name. So even the first two, you should be able to write it. So you do select province name, comma, town name from from the this one will be from the employee table, right? Yeah, to be from the employee table. Okay, so I think that one will be the next one. So we do select province name, town name. Let me separate them so that you see it clearly. Province name, town name, and then the next condition is that an aggregated count of records for each town. Consider naming this records per town, records per town. So this is it. An aggregated count of records for each town. Consider naming this records per town. All right. Okay. So that is it. We count the town name, then we name it what records per town from our location table, not the employee table, from our location table. Then we group by province name and town name. Okay, so we group by province name and town name. That is exactly what they said we should do. We should order, so it says ensure your data is grouped by both province and town name. So we group by province name and town name. And it also says that you should order your results primarily by province name. So we will group our results by province name and town name, and then order it with what? Province name. And it also says that we should do what? Within each province, further sort the towns by their record counts in descending order. So we further do the records, the counts by descending order. Whenever you type something, please, when you use the select statement, in between the select and the from, the things that come in, none of them contain or have a semicolon at the end. If you are separating or you want to display one or more columns, you separate them with commas. So this one column, and then this another column, and then the last one, it doesn't contain a comma. The last one that comes before the from, it doesn't have any comma at the end. So note that. And then from, then our table name will continue. Then it is after the from that we can have the group by or the order by. So note that too. So when I did everything, I've seen that there's a cross here. It means this line has a problem. So I realized that it is here. So I'll delete this so that I'll have my semicolon. The semicolon is the last one that will come at the end of your statement. So it means that this whole statement has ended. Okay, so you don't bring the semicolon here at the group by or here or anywhere else. So it should be at the end. Then I run this. So this is what I'm getting. And then when I come to the table or this one, it says Akachi Rural 6290, Akachi Lusaka 1070. When you come to my own, you see Akachi Rural 6290, Akachi Lusaka 1070. So we are on track. We are on track. Okay, so these results show us that our field surveyors did an excellent job of documenting the status of our country's water crisis. Every province and town has many documented sources. This makes me confident that the data we have is reliable enough to base our decisions on. This is an insight we can use to communicate data integrity. So let's make a note of that. Finally, look at the number of records for each location. So we finally look at the what? Records for each location. So let me comment this out. Okay. So we do select then location type. So in the locations table, we have a location type column. Then we also count the location type as, then we name it as what? Number of location type. So that's what I did. And then we also group by location type. So let me see what I said again. It says that so location type basically contains what the it is either urban location or a rural location. And so we are counting. Let me show you the table so that it won't be something like an abstract thing. So let me select all columns from the location table. So all columns from the location table, you see we have location ID, address, province name, town name, and then location type. These are location type. We have either urban or rural. So I think when I scroll through, you'll see urban or rural. So that is it. So we have location type, we have location ID, province name, and town name. So that is what we are talking about. So we are saying that we select the location type. So we want to place the location type, that is it is urban or it is what? Rural. But then you remember that when they are plenty, we cannot list them like that. The data becomes too plenty. It doesn't make sense. So we have to have two unique location type, which will be urban and what, rural. And that is why we use the group by here. So we group by what, the location type. And if you have noticed, anytime we use group by, we group by, most of the time we group by what we listed in the beginning here. Okay, so we group by the location type as usual. Then we count the location type. We count the number of urban, we count the number of rural, and we set it as what, or we name it as what, number of location type. Now you see that I still have a cross here. From location, there shouldn't be anything at the end, but still it is what, reddish. It means something before it is causing that. And I told you that whenever you finish here, before the from, there shouldn't be any comma. If there's a comma, it means there's another thing coming before the from. So I delete that and the red is gone. And also I'll delete this one. So I'll group by the location type and order by the number of counts I have for each location. So if I counted urban and I got 1,000 and what, I need to order them like that. So I press run. Wait, let me run it again. Okay, so when I run, you have rural being 23,740 and then urban being what, 15,900, because I said it should what, order by count. So it ordered from the highest to the lowest, and that is it. Okay, so let me comment it out as usual. Okay, so we can see that there are more rural sources than urban, but it's really hard to understand those numbers. Percentages are more relatable. If we use SQL as a very overpowered calculator, we select 23,740 divided by 15,910 plus 3 whatever. So it means that this over the total times 100. So it changes it to what? Percentage. I think that one we're not able to use it to query, because unless you know the total, then you go and punch it there direct. Okay. Uh-huh. Maybe if there's a way that we can just type it in straight, maybe later we will be taught. So again, what are some of the insights we gained from the location table? Our entire country was properly canvassed, and our data set represent the situation on the ground. 60% of our water sources are in rural communities across Majindogo. We need to keep this in mind when we make decisions. So we know that 60% are what? Are the rural communities. So diving into the sources. Okay, water source. Water source is a big table. Wait, okay, water source is a big table with lots of storage to tell, so strap in. Before I go and spoil it all, open up the table, look at the various columns, make some notes on what we can do with them, and go ahead and make some queries and explore the data sets. Perhaps you see something I don't. So here they said we should make some queries and all that. So we will look at the water source. We look at the water source. So this is the water source, okay? So you can make meaning out of it. Maybe you can query for the type of water and the number of people say for that particular type of water. Is it a shared tap or a tap in home or tap in home broken? You can use that one to get those people. You group them and then you get the total for them. And also we can, I think we can do a lot of things there. Let me see what I did. So this says my queries. So I did this at first. So I said select all columns from water source where the type of water source is what, tap in home. So if I do this, it will only select all tapping home. So that is one thing I did. And also I did this, let me comment this out. I also did this. I said select type of water source and then sum the number of people served. So we sum the number of people saving group type of water source. If it means that we will group type of water source like tapping home, then we total the number of people saved for that particular tapping home. Or we do that for tapping broken home, and then we also what? We group them. Then we order them by the sum in descending order. So when I search for this or I run this, this is what I get. You see that I have the 5 unique type of water source. So shared water tap have this number, which is I think 11 million and over. Then the well has 4 million over, almost 5 million. Then tap in home has this. So let's go and see what they also did. So here they said the way I look at this table, we have access to different water source types and the number of people using each source. These are the questions that I am curious about. How many people did we survey in total? So we look at the number of people we survey in total. So you will try it yourself, okay, before you come and check if you are correct. So some of the things you try them before you look at what Chidi Kunto will say. So the second one says how many wells, taps, and rivers are there? How many people share particular types of water sources on average? Then how many people are getting water from each type of source? I'll leave the first one to you. Try answering the rest on your own too. For the second question, we want to count. So let's see the first one. So the first one is the sum for everything. So it means that we are supposed to do the sum for the number of people served. Okay. So if we use this particular one, let me type my own query. Let me type my own query here. So I'll do select. Let me do this. I'll do select sum. So let me bring this one down. Select sum. Number of people saved. People saved. So number of people saved from water source. So from the water source table. Okay. Good. So this is the sum of all people saved. So this is 27.6 million or 27,628,140. Okay, so that is the total. It says how many people did we survey in total? Okay, so those are the number of people we surveyed in total. Then they said that for the second question, we want to count how many of each of the different water source types there are and remember to sort them. So that was what I was doing in the beginning. Let me comment this out. So this is it. So we have select type of water source and then we sum the number of people saved. So the number of people saved, when we group it, it will sum per type of water source. Okay, it will sum per type of water source. So if the type of water source is tap in home, it will sum all tap in home number of people saved for tapping home. If it is a well, it will sum the number of people saved or the number of people the well saves in total. So that is what we have done. So we have grouped by the type of water source, and then we order by what? The sum. Okay, so when we run it, sorry, when you select a code, then you run, it won't work. Like this one, it will throw an error, so that you think you are wrong. So you have to make sure that you haven't selected them. So now I've run it, and then you see share tab. This is the number. Well, this is the number, but I said it should what? Arrange it in what? From the biggest to the smallest using this particular formula. Okay, so if you don't understand why we are using the order by or select or whatever, you should go and revise the I think the model. So I came back and then wrote number one, how many people did we survey in total? So this is the formula. You can try it yourself. Then number two, how many wells, taps, and rivers are there? And that is what we did. This one. Then number three, how many people share particular types of water sources on average? So this is the question. It says, so it says select. So let me get this one off to the top. Let me bring it here. Good. So I have this one here. It says we want to do what? Oh, that was the third question. How many people share particular types of water sources on average? Aha. So we look at the particular type of water source and then we average the number of people saved like this. So we do average is AVG, then we open brackets for the average of the column name, and the column name is what? Number of people saved. So we are looking at the average for number of people saved, okay, averagely. Then we rounded it up by using the round around the average. So round will take the number itself, which is the average here, then comma, and then the zero means to zero decimal places. So that is a round. Then as what? Average number of people from the water source. And then we group by the type of water so that it will do something like this and find the average for each. So if it is shared water tap, the number of people saved averagely will be what? Displayed. Okay, so when I click on run, I think, oh, sorry, I selected the whole thing again. So I run it, and then tapping home is what? 644 people are saved in tapping home averagely. So you see, tapping home, we have tapping home, maybe 300 people are saved. Tapping home for another place, maybe 500 people. Tapping home for another state, like that. And we look at all of them and put them together by average tapping home. How many people does it save? So 644. And then tapping home broken, 649. Shared tap, 2071. Okay, so that is the meaning. And so it says, so this is uh, the first one that we did. The it says what? For each. So tap in home, when you check this, I think it is the first one that here, the sum. So the sum one, okay. Maybe try and then run it so that you check it. We check if it is correct or it corresponds to Chidi's phone. Let me run it. Okay, is it this one? It says number of sources. Oh, okay. For the second question, we want to count how many of each of the different there are and remember to sort them. Let me check. That is question 2. I think question 2, yeah. Good. So this is what we get. So that is the second one that we did. We select the type of water source and we count the type of water source. So we did this. We counted the type of water source. So that is, if it is tapping home, we count the number of. So because that is the question, they asked us that we should find, or we should find out how many wells, taps, and rivers are there. So how many wells? So we count the number of wells, we count the number of taps, we count the number of whatever. So we look at tapping home. We have tapping water, the type of water source contains tapping home, plenty. Then we count all of them, tapping home, tapping home, tapping home. Then with the well, we count all of them too. So when we do that, we group them so that we take only one of them, we count, then we bring it there. So you see, when you check this, they have tapping home to be 7265, tapping home broken 5856. So when you come here, we have 7265, 5856, like that. So we are there. Okay. Let's continue. Which of those sources stands out? It is pretty clear that although there was a drought, water is still abundant in Majidungo. This isn't just an informative result. We will need these numbers to understand how much all of these repairs will cost. If we know how many tiles we need to install and we know how much it will cost to install them, we can calculate how much it will cost to solve the water crisis. Okay, next up, question 3. What is the average number of people that are served by each water source? Remember to make the numbers easy to read. So what is the average number of people? So I think it is here, the average number of people here. So I'll bring this one here. So average number of people, we do average of the number of people served, we round it to the nearest zero, to 0 decimal places. Okay. And then we look at the type of water source. So the type of water source, then it gives us the average number of people served. Then we group by the water source. So when you group by it, will just give you the name of the water source once, and then the average for all of them, it will give it to you. Okay, so let me remove this and then run this. This is what I am getting. So when you look at their table, it looks similar to what we have here. Okay, so these results are telling us that 644 people share a tap in home on average. Does that make sense? 644 people share a tap in home on average. So what they are saying is that this is average number of people saved. So tap in broken home saves 649 people, and then well 279 per well, and then 2071, that is averagely for shared tap. But tap in home, you remember they said something about it, that a tap in a home is shared by 6 people. Okay, so if at any point in time the right type of water source to be what tap in home, and they write the number of people there, or they write the number of people served, then the number of people served for that particular tap in home is not that number. It means that when you divide by 6, uh, that is the number of taps for that. That is 7 people. Okay, because 644 means that 6 people are using a tap. So if 6 people are using one tap, then if you have 644 and you divide by 6, uh, you have about is it one something? Okay, number of people, number of tasks. So that is exactly what they are trying to explain here. So they say, remember I told you few important things that apply to tapping home and tap a broken tap in home. The surveyors combined the data of many households together and added this as a single tap record. But each household actually has its own tap. In addition to this, there is an average of 6 people living in a home. So 6 people actually share one tap, not 644. So actually 6 people share a tap for these two. Then this one's 279 share a well, 2071 share shared tap. 600. So that is the meaning. Okay. So it is always important to think about data. We tend to just analyze and calculate at the start of our careers, but the value we bring as data practitioners is in understanding the meaning of results or numbers and interpreting their meaning. Imagine we were presenting this to the president and all of the ministers, and one of them answers, why does it say that 644 share a home tap? And we had no answer. It happened to me once. I don't miss those days. So this means that one tap in home actually represents 644 divided by 6, which is the same as what? 100 taps. Calculating the average number of people saved by a single instance of each water source type helps us understand the typical capacity or load on a single water source. This can help us decide which sources should be repaired or upgraded based on the average impact of each upgrade. For example, wells seems to be a problem as fewer people are sharing them. On the other hand, 2000 share a single public tap on average. We saw some of the queue times last time, and now we can see why. So looking at these results, we probably should focus on improving shared taps first because we can see 2000 plus. Now let's calculate the total number of people saved by each type of water source in total. To make it easier to interpret, order them to the most people saved by source is at the top. So what we have is the total for each, I think that one is here. So that one is the sum of the people. So that is when I put it here, I'll have select then type of water source, then the sum. Then we go by the type of water source, then it will sum the number of people saved for each of them. So we have this, and we can say group by and then order by. So I can do order by order by number of people. So number of people, you won't write number of people, you just copy this and paste it, and then we run it. So this is it. So I'll do descending, descending. Then it will arrange it the way we want it. When it comes to the table, you see that it matches the Kunto's own. It's a little hard to comprehend these numbers, but you can see that one of these is dominating. To make it a bit simpler to interpret, let's use percentages. First, we need the total number of citizens, then use the result of that and divide each of the sum by that number times 100 to get percentage. Make a note of the number of people surveyed in the first question we answered. I get a total of what? 27 million citizens. And that is what we got in the beginning. We got about 27.6 million people. So let me see, I have it here. So I have this. Yeah. So I select type of water source. I sum the number of people, but then you see when you sum the number of people, we are doing something here. We are summing it based on the type of water source. So if you take tap water, because we are grouping it, so you should know that when we group it, we take it one after the other. So when we take a type of water source, which will be shared tap, then it will take the sum of the shared tap number of people served divided by the total population, then times 100, which will change it to what? Percentage. And then after it has changed everything to percentage, we run it to the nearest or to zero decimal places. We're using the round uh, function. Then we do as, and then we give it a name. So this one is going to give us that result. Let me see. Good. So this is the result. So tap in home had 17%. Share tap had what? 43%. So that is the meaning. So that is the meaning. So I think we got it here. Yeah, so it's here. Share tap is 43%. So here. And then we have well 18. So well is 18. So we are on track. We are on track. So 43% of our people are using share tabs in their communities. And on average, we saw earlier that 2,000 people share one share tab. By adding tap in home and tap in home broken together, we see that 31% of people have water infrastructure installed in their homes, but 45%. So here it says 31%. So that is putting the tap in home and tap in home broken. So when I put 17 together with 14, I'm going to get 31% of people who have what? Water infrastructure installed in their homes. So that is the ones installed in homes. But 45% of these taps are not working. So 45% is what? The 14 out of the 31. 14 of them are not working. That is tap in home broken. So they are broken. So this isn't the tap itself that is broken, but rather the infrastructure like treatment plants, reservoirs, pipes, and pumps that save these homes that are broken. 18% of people are using wells, so you can see it, but only 4916 out of 17,383 are clean, which is equal to 28% from last week. So from last week, if you can remember, they said only 4,916 out of 17,383 are clean. So this number of uh, taps or whatever, the number of water sources, they are clean out of the 17,000, which is will represent what 28%. At some point, we will have to fix or we will have to fix or improve all of the infrastructure. So we should start thinking about how we can make a data-driven decision how to do it. I think a simple approach is to fix the things that affect most people first. So let's write a query that ranks each type of source based on how many people in total use it. So rank should tell you we are going to need a window function to do that. So let's think through the problem. So let me remove this. Okay. So this is my rank formula. This is my rank formula. So I select type of water source, then I sum the number of people, and then I am ranking. So this one is a formula that was taught in the models. So you rank, then you order by sum of this. So I don't know how to explain this, but if you don't understand this particular portion, you have to visit the model and then read about it, because this is a window function. We are saying that you should rank, then order the sum. So window uh, the window function, it is going to divide the data into partitions, like something like a partition. So but this particular one is not partitioning because we didn't indicate the partition. We are just ordering it. So it will cut across all values, or yeah. So that is what we have in this case. So when I run, you see that the rank population is here. It will rank them. Okay, it will rank them based on what? The sum of number of people saved in descending order. So that is why it is descending. So it is ranking based on this, and then it will do in descending order. Okay. Okay, so here it is telling us what we will need and all that, but we have done it already. Um, so here, let's move on. So okay, so we should fix shared tabs first. So this is the meaning of what we've done. So it says this one has the highest number of people saved. So we should fix this one first, before second, before third, before fourth, and fifth. Okay. So here it says, so create a query to do this and keep these requirements in mind. The sources within each type should be assigned a rank. Limit the result to only improvable sources. Think about how to partition, filter, and order the result set. Order the result to see the top of the list. So we are going to do something similar to that. So I think I have this one. And so this one we partitioned it using a type of water source, and also we ordered it. Okay. So we select source ID, then type of water source, number of people saved, then we ranked using a partition for type of water source. Then it will partition it. So when it partitions, it is going to, instead of ranking it 1, 2, 3, 4, 5 throughout, it will partition each water source and rank it. it will partition each water source and rank it. So share tab, then it will rank from first to whatever. Then it will come to well water. I think that is what will happen. Yeah. Uh, yeah, so that's what is happening here. So if it is river, it will rank it first before it will rank everything river first to wherever it will end. Then it could go to tap in home, then rank those people there. Then it will go to the next like that. So it won't rank across from the beginning to the end. No, it will rank based uh, on the particular type of water source. So if we do it like that, with that is what I did now. Okay, so yeah, so this is what I've done here. You see that it has partitioned it like that. So in our case, you see that it doesn't really look like this. That's it is like this. When you go and check for share tab, you see these values there, and then you see that it is the same as what is there. So by using rank, teams doing the repairs can use the value of rank to measure how many they have fixed. But what will be the benefit of using dense rank? Maybe it is easier to explain to the engineers this way, or priority feels a bit more natural. So they are saying using dense rank, you can go and try that one too and see. And then they ask, what about row number? Since each source now has a unique rank, teams don't have to think whether they should repair this or that first. So when you use row number, no matter the number, whether they repeat or not, it will just number them from one to wherever it will go. So that one, we do it like, okay, we'll repair this one first before this one. It doesn't matter whether they have the same number of people. So try the different ranking functions in queries. Imagine yourself in an engineer's boots and try to interpret the priority list. Thinking about the user of a table helps us to design the table better. In that line of thought, would it make sense to give them a list of source IDs? How will they know where to go? Okay, so try the different ranking functions in queries. Imagine yourself in engineer's booth and try to interpret the priority list. Thinking about the user of a table helps us to design the table better. In that line of thought, would it make sense to give them a list of source IDs? How would they know where to go? So we come to analyzing queues. Okay, this is the really big and last table we will look at this time. The analysis is going to be a bit tough, but the result will be worth it. So stretch out, grab a drink and let's go. A recap from last time. The visit table documented all of the visits our field surveyors made to each location. For most sources, one visit was enough, but if there were queues, they visited the location a couple of times to get a good idea of the time it took for people to queue for water. So we have the time that they collected the data, how many times the site was visited, and how long people had to queue for water. So look at the information we have available and think of what we would learn from it. Remember, we can use some data time functions here to get some deeper insight into the water queuing situation in MyJindogo, like which day of the week it was and what time. Okay, these are some of the things I think are worth looking at. So it gave us four questions again for us to look at. So how long did the survey take? So we look at the time. We look at the time. the if it is how long, they will look at when they started and when they ended, so that you can calculate the time between them. What is the average total queue time for water? What is the average queue time on different days? How can we communicate this information efficiently? Try to answer some of these questions. Think of the data you will need to answer each question and how to transform that data into the right form to answer each question. Then make some queries to try and answer them. You learn all of the skills you need, so give it a try. So I had to read up a bit on control flow, data, whatever. So this one, let's forget about it. Look at visits, especially the time of record column. It is an SQL date time data type. So we can use all of the date time functions to aggregate data for each day and even per hour. So question 1, to calculate how long the survey took, we need to get the first and last dates. Which functions can find the largest, smallest value and subtract them? Remember, with daytime data, we can't just subtract the values. We have to use function to get the difference. So here, if we want how long it took for the survey to for them to survey or to finish the survey, then he said we should go to the is it the visit table or the um, let me look at it again. Okay, I think it will be in the visit table. Okay, so let me select all columns from the visit table. Then let's see something. You see, in the visit table, we have visit count, we have time in queue, assigned a group, then we have time of record. So you see, this contains our date. So it means that we have to look for the highest date or the current date or the last date. Let me see the starting date and then the current date. That is it. So the highest, we will say the maximum date and then the minimum date. So that is what I was doing it here. So I had to select the minimum time of record. I want to display these things so that you see. That's why I have them. They are not really necessary for us to display them, but then because I want you to see what is happening. So we add them minimum time record. So it will go to the time record column and look for the minimum date for us. The date that is small. Then it will look at the maximum date. So that when we get the maximum and minimum date, we can find the difference between them and it will give us the difference. And we can't just say minimum minus maximum. We can't subtract date like that. So we have to use the date diff. And the date diff has to contain two dates. The biggest date first, comma, and then the second or the minimum or the small date. So I have my maximum from the record. It will bring out the maximum date or the dates here. So my comma will come and then the minimum will take out the minimum or the smallest date. And then that is my date diff as number of days. So whatever I'll get will be the number of days. So when I run this, you see that I'll have my minimum date here. My maximum is what? 14th July 2023. And this is what? 1st January 2021. So you see, they started in 1st January 2021 and ended in what? 14th July 2023. And that is what? 924 days. So 924 days, when we convert to 2 years, you see that we'll have somewhere around 2 years and some days. So 2 years and some days. So you know what is happening. So that is what we have. When I do it, I get 924 days, which is about 2.5 years. Just imagine all the visits, meeting all those people on the ground for 2 years. So imagine doing the survey for 2 years, going around and all that. So that is what they are saying. It is sometimes easy to see data as meaningless numbers and text, but remember that each person in that queue that day could have been someone who walked 10 kilometers, queued for 4 to 5 hours, and then walked all the way back home. Often these are children who need to do this, so they have less time to attend school. It makes me sad and angry that we got to this point. Anyway, mambo yatakuwa sawa, as my mother used to say, things will be okay. The important thing is we are doing our part to stop that kind of thing from happening. So question 2, we say, let's see how long people have to queue on average. Imagine Dogo. So on average, how many people will queue or how long do people queue? So you say they are asking how long people queue. That means we are looking at what? The average or the time they wait. Okay. Let me say something here. Let me comment this out and bring out the visit table again. So time in queue is here. You see that we have time in queue. So we are looking at the average that people wait. Okay, that is what they are saying. Let's see how long people have to queue on average. So on average, how many people queue? Or how long do people queue? Keep in mind that many sources like tabs in home have no queues. So tabs in home, they don't have queues because it is in your home. So you don't have to queue. These are just recorded as 0 in the time in queue column. So when we calculate averages, we need to exclude those rows. Try using null if to do this. Okay, so they got 123. So let's also try it. So they are saying that with the tab in home, it will give you 0 for the time in queue, and we don't want to add it to the average because average is calculated as the number of so average will be like if we have 5 people with marks, so we have your mark divided by the total. Okay, so averagely your mark divided by sorry, it will be the total marks divided by the number of people. So it will be the total marks divided by the number of people, and that will give you the average for that particular group of people. So we want to find the average, and we are looking at this. So this one, oh wait. So they said that when it is what? The time in queue is what? 0, then we cannot add it to the average. Well, if we have 5 people and one person gets 0, and we don't want to use the 0, it means we will have 4 people instead. So if you add the 0, it will increase the number of people and it will affect the average because the number of people will be, let's say, 7, and then about 3 of them are 0. Imagine. So you add the sum of the 4 people divided by the whole 7. Okay, meanwhile it's supposed to be 4 because the other ones they got 0, so we are not accounting for that. So they said we should remove that one, so I did this. I used the if statement. So this is it. This is the if statement. The average is inside the average. So my if statement says if time in queue is equal to 0, then it should be now, else time in queue. So if it is 0, then it should be now, because when it is now, it will not add it to the average. That is what happened here. It will not add it to the average. That is why it says you can use now if. That I prefer to use this one. And this thing, whatever it will return, we add it to the average and find the average. So it says time in queue is 0. Now, other than that, if it is not 0, then we find the average of time in queue. So it will look at this, is it 0? No, then it will bring it here. This one, is it 0? Then bring it here. So at the end of the day, all of them will add up then it will find the average for that. So the one that is 0 will not be added, then we find its average. So that is what we have here, and that is 123.2574 minutes. So you see that they also go 123 minutes. So on average, people take 2 hours to fetch water if they don't have a tap in their homes. So if they don't have a tap in their homes, they spend about 123, approximately 123 minutes. That may sound reasonable, but some days might have more people who need water and only have time to go and collect some on certain days. So question 3. So let's look at the queue times aggregated across the different days of the week. So we want to look at the queue times aggregated across the different days of the week. So day gives you the day of the month. If we want to aggregate data for each day of the week, we need to use another daytime function, day name. As the name suggests, it returns the day from the timestamp as a string. Using that on the time of record column will result in column with day names, Monday, Tuesday, etc. from the timestamp. So we can use day name to extract the day name from the date and time. Because when you use day is going to return something like 1, 2, 3, 4, 5, 6, 7. Where 1 refers to, I think, Sunday or so, and then 7 refers to, is it Saturday or something. So they are just integers. But if you want the day name, you have to do day name of that particular date. To do this, we need to calculate the average queue time grouped by day of the week. So we will look at the day of the week, we group them because day of the week will be listed plenty times. So let's do something here. Let me comment this out. So question 3 will have question 3 will have we will select day name of time of records. So time of record, this one will give you the date. This is the date. And when we write day name, it will extract the day name from the date. And then it will label the column this. Then it will also find average. Let me comment this out. Okay. And then remove this. So I want to run this so that you look at something here. Let me do this. Let me remove this one too, and then so that we will have select day name as day. So we want to list the day names. Let's look at something. So you see that we have Friday, 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 Friday goes and then Monday, 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 Tuesday. That's not what we want. So we have to group them. That is why we have the group by, so that it will group them. So Friday will be only one of the Fridays, okay, and then it will group them like this. So you see I have them like this, so now it doesn't repeat. So that is why we have the group by. So the day name is giving me the day name, and I group it so that it will not repeat them, because the different dates will give you some of them will give you the same day. We have only 7 days in a week, so the date, so 1st January day may be the same as maybe 4th February or 5th, whatever. So that is what we are talking about. So after that, we are saying that we will find the average. So I will say if the time is 0 now, other than that, give me the time. Okay, and that is what I did here. Um, this will look so plenty in your eyes, so let me break them down so that you look at them. Okay, so I'll bring my comma. So this is one column, and then the round is another column. So that's what I'm doing. I'm saying if, so you can write this if statement. If the time in Q is 0, don't find the average. So put it now. Other than that, put the what time in Q there. And now when you put time in Q there, you find the average. So average, opening bracket, and then I'll put the if statement in it. And it will find the average of whatever it returns. It will put them together and then find the average. And after that, when I find the average, I have to round it to the nearest whole number or something. So there to the one decimal place. And that is what I have here, this long formula. Then I put the name of the column here. Then I group it by the, so I've done it already. Then I run it. So it will find the average for Sunday, to find the average for Monday or whatever, to do that for me. So this is it. So average queue time for Friday 120, for Saturday 246. So you see that average queue time for Saturday is huge. So this data crowd will tell you that, oh, Saturdays people queue more than any other day. For Saturdays people are in the house. So some of these things you have to understand about the data. So you see that is exactly what is here. Wow, okay, Saturdays have much longer queue times compared to the other days. So question 4, we can also look at what time during the day people collect water. Try to order the result in meaningful way. So we want to look at the time people collect water. So average queue time is the same thing here. But this time around, instead of day, we will not do day. So let me comment this out. So this is the fourth one. So it's the same thing, but this time around, instead of day, we'll do what? Hour. The hour of time of record, and it will give me the hour. But you see, the hour is going to give me 1, 2, 3, 4, whatever for the hour. It won't write 6 o'clock or whatever. Then I find the average using the formula I used previously. The same thing here. Then I'll group by the time of record and order by the time of record. So when you check this, you see that it is 6, 6, 7, 8, but it doesn't make sense. So we will polish it. So polish this and make it 6 o'clock, so that when you see 6 o'clock, you see that it is 6 o'clock. So this is what we did. We said we used something called time format. So the time of record, we use the time for that. And then I don't know if so time, when you use time for time of record, let me comment this out. I think I have to take it one by one. So let me do select. So select time, and then time of record. Okay, from visits. So if I do this, this is what I'm getting. See, look at the time. This is how the time displays. But when I use time format, I am formatting the time so that it will look like what I want. So I put the whole of the time inside time format. So I write time formats like this. I put the whole thing inside a column, inside a bracket. So when I run this, look at the time it will give me. Hold on. It looks like I've opened something. Oh, so I wrote visits. So visit, is it visits? Visit. Uh, I don't know why it is not showing. I've done something wrong somewhere. Okay, sorry. The time format, I wrote time format. I didn't complete it. So comma, then I put the format in quotes. So the format, I want it to be hour colon 00. So that is how we want it to display. Then I run it. So you see, now this is what we want. So that is exactly what I've put in here in the select statement here. So we name it what hour of the day. So let me clean this and then open this up. So you can see that we have the time here as hour of the day. That is one column, then comma. Then we find the average of whatever we want to do. This one we have typed it before. So we find the average using the if statement, then we round it up, and then we group by, this time around we group by what hour of the day. So you see, hour of the day we have 9 o'clock, 9 o'clock, 9 o'clock. No, we want only one of them. So we group by them. We group by the hour of the day, and then we order by the hour of the day. So when we run this, 6 o'clock will appear only once, 9 o'clock will appear only once, whichever will appear only once. So you see, it is showing us clearly. So let me comment that one to out. So that is exactly what they also did here. Good. So you see, 6 o'clock is 149. That is the average. So 7 o'clock the same, 8 o'clock the same, and all that. Then it says, can you see that mornings and evenings are the busiest? It looks like people collect water before and after work. So it looks at this one and sees, oh, 6 o'clock, 149 minutes. 7 o'clock, 149. 8 o'clock, 149. By getting to 9, you see that the number is, the minute is reduced. By evening, 7 o'clock, see, 140 something again. So you can see that evenings, the times, the queue times are high, and then mornings too, the queue times are high. So that is what they said. So it says, it looks like people collect water before and after work. Wouldn't it be nice to break down the queue times for each hour of each day? Okay, so they want us to break down the queue times for each hour of each day. In this case, it is for uh, across 6 o'clock for across each day. So it could be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Average for 6 o'clock. That is 149. So we go to Monday morning, 6 o'clock, Tuesday morning, 6 o'clock. We look at it and it is the average. But they are saying that we should break it down so that we have Monday alone, 6 o'clock, 7 o'clock, 8 o'clock. Then we look at Tuesday alone all this time, Wednesday all this time, like that. That is what it is said here. Then they said in a spreadsheet, we can just create a pivot table. So if it is spreadsheet, you could have created a pivot table. So pivot tables are not widely used in SQL, despite being useful for interpreting results. So there are no built-in functions to do this for you. Sometimes the data set is just so massive that it is the only option. For now, for rows, we will use the hour of the day in that nice format and then make each column a different day. So we use columns to get different days, and these are the things that we use. So to filter a row, we use where by using case in select can filter columns. You can use so they are all there. So let me show you. So we came here and then we used cases. So we say select, then we select the time format, the one that we know. So this one will be there. Then the first column will be maybe Monday, second Tuesday, and this is how we are doing it. We said you find the case, you say case when the day name of the time record is Sunday, then we what? We return the time in Q, but we find the average of that. So when it is Sunday, we do that, then we find the average of that, then we label that column as what? Sunday. So that is what's happened here. So we do that for every one of them. Let me uncomment them. Okay, so we have this round average, forget about them for now. So we have case, then when the day name, okay, we look at the day name for the time record. When it is Sunday, then we return what? The time in Q. So when it is Sunday, we return the time in Q, else it should, so if it is not Sunday, we should return now for that particular column. If it is not Sunday, it is now, because we want to find the average for only Sunday. Okay. So if we are finding the average for only Sunday, then the Monday average, the Monday values, and then the Tuesday and whatever, it will put all of them to now, and it will make sure that only Sunday appears. Only the time in queue for Sundays appears. For Sunday, Monday, for Sunday, 6 o'clock, 8 o'clock, 7 o'clock, 9 o'clock. For Sunday, all the times. It will put all of the time in queue for all the times and put them together for you. Okay, so that is what it is doing here. So else you should put what? Now. Then it comes to the next one. It does the same thing. Case when the day name is what? Monday, you should put time in queue, else now. So we did that to the end where we ended it. Then we said where the time in queue is not 0. So when it is not 0, we do this, okay? Because some of them, the time in queue are 0 and we don't want to add them to. Then we group them by the time format and then the order by whatever format. So that is it for this particular one. Okay, so we run it. And this is what we got. So it comes to Sunday, 6 o'clock, 7 o'clock, 8 o'clock, so 6 o'clock, the average, 7 o'clock, 8 o'clock, 9 o'clock, like that. Comes to Monday, Tuesday, Wednesday. So you see the table. It looks nice. Okay. So that is exactly what happened here. And they've written it long like that. So this is what they also got at the end of the day. So it says, see if you can spot these patterns. Queues are very long on a Monday morning and Monday evening as people rush to get water. Wednesday has the lowest queue times, but long queues on Wednesday evening. People have to queue pretty much twice as long on Saturdays compared to the weekdays. It looks like people spend their Saturdays queuing for water, perhaps for the week's supply. The shortest queues are on Sundays, and this is cultural thing. The people of Majindugu prioritize family and religion, so Sundays are spent with family and friends. We built a pivot table in SQL. The thing I want you to remember today is SQL is set for of tools we can apply. By understanding case, we would build a complex query that aggregates our data in a format that is very easy to understand. To take it one step further, I made a graph. If you copy the pivot table into spreadsheet, you can too. So we can also copy what we have created into a spreadsheet and use it to create a graph. So when you have this table, you can come here. So this table, you see here, export. So you can click on export, and then you save it. So you save it, you see that it will save it as CSV. So that when you go to Excel, you just go to Excel and import and then trace that CSV file. So you know how to use Excel to get CSV file, and then it will automatically do everything for you. And then you go to graph and plot them, and then it will look nice like this. Okay, yeah, because my time is it's becoming too long, so I don't want to spend much time on this. So when you export it, you get it to CSV, you open your Excel file, your Excel application. You open your Excel application, and then you go to insert, and then I think, is it insert? No, data, sorry, data, and then from text or CSV, good. Then you look for the CSV file. In my case, I saved it on the desktop. So I have time record, then I click on it and then import. So I import it. So I load. So you see, it has been imported nicely. Excel has even added AM and PM to it. So here you can click anywhere inside the table, go to insert, and then go to the graph, and then choose the graph that fits. So you see that I've chosen the graph that fits, and this is how it looks like. I can beautify it. So you have learned Excel, so you'll be able to you have learned, is it Google Sheet? Yeah, Google Sheet. So you can use it to do whatever you want to use it for. So after that, let's see if that is all. What do you think about this chart? As we consider presenting this to President Naledi, think about how we can use our findings to tell the story and bring focus to the patterns in the queue time. So when you look at the chart, you see that they have indicated the legend here, 6 o'clock to 7 o'clock. So you see that 7 o'clock is the deepest one, that is at the far end. So you see that on Saturdays, look at this, it's long. Saturday, the queue time is long. And then in the mornings are yellows, the yellow ones. So this is the longest. So you see on Monday morning, early in the morning, people queue long. Okay. So you can see it here like that. And then I think on Monday evenings, getting to the evenings, they queue more after Saturday. It is Mondays and I think Wednesdays. So you can analyze the data like that. So water accessibility and infrastructure summary support reports. So these are I think the summary report for the whole thing. Practical solutions. So you read all these. And these ones, they are not also telling you to do anything. They are just giving you the insight. So you can read through it for yourself. Please, this PDF, I got it from the portal. That is in your here. When you come to the project, I think project this one, sorry, this particular one. So the first one, when you click on this, you can read it and then you are through with it. All right, so thank you for your time. I hope this video helps. Thank you very much.